Factoring an expression in algebra is often an effortful, artful, and therefore quite challenging process. So the only reason that we invest so much time and effort into practicing techniques for factoring expressions is that factoring allows us to do something with polynomials that we would not otherwise be able to do. Namely, it will give us a method with which to solve equations that have polynomials in them. In this example, we'll look at how the technique for factoring a quadratic trinomial, which we saw in the previous video, may be used to solve an equation that has a quadratic trinomial in it. Remember that the end goal of any problem in algebra which asks you to, quote, solve, is that we must discover values for the variables that balance both sides of an equation. So whereas in a factoring problem, your answer is typically an expression involving a product of several expressions that give us the original back, in a question that asks you to solve, we begin not with an expression, but with an equation, and we should end not with another expression, but with specific numerical values that variable should take. In this example, we begin with the equation x squared plus 6 is equal to 5x, and we are asked to solve this equation for x, which means that we must end up with a statement that looks like x equals something. So how do we get there using the factoring method that we saw in the previous video? The first step is also the most often overlooked until you get some expertise with working with these equations, but it may be the most important. Factoring is only a useful method for solving an equation when one side of that equation is equal to the constant 0. If that's not the case, as it's not in the equation x squared plus 6 is equal to 5x, then our first priority is to make that the case. Make one side of your equation equal to 0 by subtracting terms from one side to the other. In our equation, we can accomplish this by subtracting 5x from both sides and giving us the new equation, x squared minus 5x plus 6 is equal to 0. That 0 on the right-hand side is fundamental to this technique. If you don't have it, you can't move forward yet. But as soon as one side of our equation is equal to 0, now we can use factoring on the other side. Our left-hand side, x squared minus 5x plus 6, is a polynomial expression whose highest exponent is 2 and which has 3 terms that are not like to one another. That makes it a quadratic trinomial. And since its leading coefficient, the coefficient in front of x squared, is 1, we can use the sum and product method that we saw in the previous video to try to factor it. That method will require us to find a pair of integers, if they exist, which multiply together to give us 6, and which add together to give us negative 5. So starting by thinking of numbers which multiply together to give me 6, I might think about positive 6 and positive 1, positive 3 and positive 2, but then also negative 3 and negative 2, since negative times negative is going to give us a positive, and negative 6 and negative 1. Of those possibilities, the one which also adds together to give us negative 5 is the pair negative 3 and negative 2. Using the sum and product factoring technique, we may therefore factor the left-hand side of this equation into the product of binomials x minus 3 times x minus 2. At this stage, having accomplished the task of factoring, sometimes students forget what they're doing midstream and forget that there's an equation still involved. We still have an equal sign, and we still have a right-hand side, which is 0. So we're not done yet. We still have to discover what value x should have. Discovering the value for x uses a strategy that factoring makes possible by using a property that exists in the system of real numbers. The property is called the zero factor property, and it states that it is impossible to multiply two numbers together and get an answer of 0 unless one or both of those original numbers was itself equal to 0. The number 0 is unique in this property in the real number system. We cannot multiply together to get a product of 0 unless one of our original factors was already 0. We can leverage that fact by taking our equation, which is now a factored expression on the left-hand side and a 0 on the right-hand side, and splitting that single complicated equation into two separate, simpler equations by giving each one of the factors its own equal to 0. This step has replaced one challenging equation with two much less challenging equations. And the path forward is then just to solve each one of those simpler equations to discover values for x. I can solve x minus 3 is equal to 0 by adding 3 to both sides. I get a solution, x is equal to 3. And I can solve x minus 2 equals 0 by adding 2 to both sides and getting the solution x equals 2. So at the end of this process, we now have values. We actually have two different values that the variable x can take that will balance, make both sides of the original equation the same. X equals 3 and x equals 2. And so we will list both of those as our solutions, x equals 2 and x equals 3. So to use a factoring technique to solve a quadratic equation, the most important first step, and we can't do any factoring until we're done with this step, is to use subtraction to make one side of that equation equal to 0. Until you have a 0 on one side, you cannot go forward. But once you have a 0 on one side, then you can start to think about factoring the other side. In this example, we had on the other side a quadratic trinomial whose leading coefficient was 1, which meant that we could use the sum and product method, as you see up here, to factor it into the product of binomials x minus 3 times x minus 2. And that's when the real magic happens at the next step. Because when a product of two things is equal to 0 in the real number system, it means that either the first factor was itself equal to 0 or the second factor was itself equal to 0. In other words, we can split this one challenging equation into two simpler equations and solve each of those simpler equations individually to discover our answer. Notice also, something happened in this equation that hasn't happened in the other equations we've solved in this course so far. This equation had two different solutions that we need to report both of. That didn't happen when we were solving linear equations, but it can happen, though it doesn't always happen, when we solve quadratic equations. And the fundamental theorem of algebra tells us that the reason for that is that the highest exponent here is a 2. The theorem tells us that that highest exponent gives us a limit on how many solutions an equation might have, but it could have up to that number. So here, because our equation had a highest exponent of 2, there was a possibility that actually came to pass that there were two different solutions for this equation. And factoring, after first making one side of the equation 0, was our method we can use to find those solutions.